Welcome to our first pre-OS vote webinar featuring an introduction to our PKCS 11 version 2.40 standard. Our speakers today are the technical committee chairs, Valerie Fennick and Bob Griffin. Welcome.
Thank you very much, Jane. My name is Valerie Fennick. I work at Oracle Corporation. I manage the Solaris Cryptographic Technologies team. I've been involved with PKCS 11 for a number of years, and I'm happy to be a part of this technical committee with OASIS.
Thanks, Valerie. And this is Bob Griffin. I'm Chief Security Architect at RSA, the Security Division of EMC. I've also been involved with PKCS 11 for a number of years and was the convener of the technical committee when we decided to move it into OASIS back in 2013. So, Jane, if you would, next slide. There we are. So I'd like to begin the webinar by doing an overview of the history of PKCS 11, and then hand off to Valerie about halfway through to talk about exactly what we're doing in the 2.40 release, the first release that's coming out under the auspices of OASIS. The standard, as I'll talk about in some detail in a moment, began 20 years ago, more than 20 years ago now. The intent of it was to really create a way of managing security objects across their life cycle for use in a broad range of devices, from simple identity cards to more complex storage devices like hardware security modules. The capabilities that we provided in the standard included operations, attributes, and objects. For the objects, it included a broad range of cryptographic types, from simple symmetric keys through complex public key infrastructure models. For all of those objects, there were attributes defined appropriate to those objects and operations on those objects that allowed you to do lifecycle operations such as create, manage attributes, delete the object, and so on. The services allowed you to install those objects into various kinds of devices, to remove them, to distribute and propagate them, and so on. And doing that within an architecture that allowed a separation of the algorithms and other mechanisms by which the objects were created and manipulated from the base objects, attributes, and operations that form the core of the standard. That allowed us to do significant extensions of the standard over time, including the creation both of new kinds of objects that were industry standards themselves, but also arbitrary objects and extensions that were unique to various vendors. Next slide, please. PKCS 11 has been important for a couple of reasons. It has been the primary vendor-independent cryptographic standard for device allocation, for cryptographic object manipulation. Was the foundation of manipulation of smart cards, in especially Unix environments, also within browsers such as Firefox and Chrome, and it's been the foundation for fundamental cryptographic APIs in both Solaris and other Unix environments, including, for example, Red Hat Unix. Next slide, please. That device independence that I mentioned is applied across a broad range of devices, including ones that are shown here. At the bottom, you'll see various smart cards, ones that were often used for identification, authentication, but also in other kinds of devices. For example, at the top of the screen are hardware security modules and other devices that do secure storage and manipulation of keys and other objects. On the right-hand side, the Solaris operating system has been a very important instantiation of PKCS 11 and is used successfully within cryptographic libraries, as has been done by other vendors as well. Next slide. So let me then talk about the history a little bit and what we've done over time with this standard and how we got to where we are today as an OASIS standard. Next slide. Again, as I mentioned, it's been around for more than 20 years. It was launched by RSA in 1994. as a standard that was written by a number of key scientists at RSA, Bert Kaliski in particular, but also included substantial industry input even into the initial specification from folks as varied as Peter Gutman, for example, Eric Young, and other members of the larger cryptographic community. That resulted in it becoming really a de facto industry standard, even though it was created under the auspices of a single vendor, representing that breadth of contribution with which it began and with which it continued. It addressed what was clearly a critical need at that time, that is having a way to manage effective and securely the manipulation of keys and other cryptographic objects across a range of devices and mechanisms. And that's continued to be the goal of the standard over time, including the transition into OASIS about 2 years ago. Next slide. The timeline shows some of the major milestones of our development of PKCS 11 from its initiation back in 1994 through a series of revisions. The first major revision into a 2.0 spec in December of 2007. At that point began a number of point releases of the standard, 2.10, 2.20, and then 2.30, which I led the work on, which began around 2008 and continued up through 2009. At that point, we began to feel inside RSA that the representation we were getting in the standard was not as comprehensive and broad as we had had in the earlier versions of the standard, and that we began to feel that in fact it needed to be within a much broader and well-recognized organization to ensure that the standard continued to represent really a broad consensus across the industry. That's what led us at RSA, with the urging and support of a number of our colleagues, including Valerie and folks at Oracle, to move the standard into OASIS. We worked through the legal aspects of that, and in December of 2012 announced that decision and agreement with a number of major players in the industry supporting that transition. We had our first gathering of the committee in 2013, in March of 2013, including virtually all of the major players in cryptographic standards in the industry, and have continued that work over the past year and a half, resulting in November last year the passage of the committee spec that has been out for public review by OASIS membership now for about 2 months, and which is now ready for consideration as an OASIS standard, a set of OASIS standards. Next slide, please. As I mentioned, the work on 2.30, which we did back in 2009, really represented, we think, a good foundation point for the ongoing work, but felt that it was itself not ready to be moved into a standard. And so we took that work and decided to bring it over into OASIS. Next slide, please. Let me talk then about what we've done in OASIS and what it means for us in having the standard inside OASIS. Next slide. I've been involved in OASIS for a number of years. I was the co-chair of the key management standard KMIP, which we brought into OASIS back in 2009. We had recognized that OASIS represented really one of the most important standards organizations, and the one that we felt would help us most effectively bring about a strong industry consensus around this standard. It had been more than 10 years since we had 2.20, and so it was very important to get it moving again. And although 2.3 had never been ratified as a standard, the work that we had done in that version, which I'll talk about in just a moment, we felt was important enough to use that as the version that we brought into OASIS. Next slide, please. The participation included, as I mentioned, a broad range of critical players in cryptographic activity across the industry. There were also a number of products from those companies and from other vendors who are not necessarily part of the committee that represented that standard, and who actually then, in some cases, participated in interops that began first in 2013, that represented the chance to actually try out both existing capabilities within the standard, but also the new work that we're doing inside PKCS 11 version 2.40. We were also able to draw on a number of organizations in terms of editorial support, including folks from Oracle, including Valerie, myself from EMC, Chris Zimmon from Bloomberg, John Liesbauer from Quintessence Labs, and Tim Hudson from Cryptsoft. The editorial team proved very strong and was really instrumental in driving forward this new version of the standard. Next slide, please. As I mentioned, we also have done a number of interops. The most recent one was in 2014. It included a number of devices that instantiated the PKCS 11 client side, and a number of libraries and a number of clients that instantiated in the applications the client interface for PKCS 11. So that included, for example, Oracle on both sides, the Cryptsoft libraries on both sides, support from Vetian on both sides for metric, as well as CryptoSense as a client-only application. Next slide, please. That interop took place at RSA Conference 2014. It included a very strong group from all of those vendors. The booth was extremely well attended and showed really in an extraordinary way the vitality of the standard and the commitment of the industry to that standard. Next slide, please. So let me then just talk a bit about the version that we brought into OASIS as the background to the changes we've made in the standard with reference to the 2.40 standard that we're bringing forward now. So next slide. Most of the work that we did in version 2.30 was focused on mechanisms, that is algorithms and ways in which the standard would be instantiated. There were, in fact, new mechanisms related to cryptographic standards that had been emerging in the industry. For example, the GOST set of algorithms that were very strongly supported within Russia and other countries in Eastern Europe. The SEED algorithms that were very strongly supported in Korea, and also trusted platform module support that was very important in terms of being able to manage the propagation of cryptographic material, including both keys and seed records into trusted platform modules, that work that was done inside organizations like TSG. In addition to that, there was also enhancement to existing mechanisms, AES, for example, perhaps at this point the most fundamental set of algorithms for cryptographic operations, but also other algorithms like Blowfish, for example, in terms of strengthening the P11 support within that environment as well. Next slide. So in GOST, for example, which is a block cipher using a 64-bit block size, 256-bit keys, that standard, which is maintained by the Euro-Asian Council, was an important one within a smaller segment of the overall world community for cryptographic algorithms, but important enough that it was critical that we find ways to support that within P11, showing how the base objects, mechanisms, and attributes could be supported within that algorithm and used, therefore, within standard devices, HSNs, and so on. Next slide, please. Similarly for seed mechanisms, this standard that was established about 15 years ago within the Korean Information Security Agency, because it's used so broadly within the South Korean industry, it was very important, again, to find ways to allow support for PKCS 11 objects and attributes and mechanisms and operations using those algorithms as well. We actually created a new key type in that case called CKK seed, with a general block cipher key type, a length of 16 bytes, and the work in this area was strongly supported by our colleagues in South Korea. And next slide, please. And finally, for trusted platform modules, it was important to find ways to support largely existing algorithms, such as RSA, for example, within those environments using the standard operations provided by P11 in the same ways we use them with hardware security modules, for example. There were relatively small modifications of the standard in this regard, mainly to introduce mechanisms that allow the manipulation of these objects. But there were also some small operations to related standards as well, in particular to the PKCS 1 standard and also related one-time password standards, allowing you to deal with the propagation of these objects into these kinds of trusted computing group environments. So that was what we did in 2.3, and at this point I'd like to hand over, as we move to the next slide, to Valerie to talk about what we're doing in the version 2.40 that is now part of the work in OASIS. Valerie, over to you.
Thank you so much, Bob. I really appreciate it. So Bob told you about where we've been, and now I'll tell you what we've been doing for the last 2 years. It's actually been a pretty exciting road. Next slide, please. So we got together quite quickly at RSA in 2013, or actually just after, and started this technical committee and dove right into work. As noted by Bob, it had been more than 10 years since our last official standard. Some vendors had gone ahead and moved forward to 2.30, and others were waiting for an official rubber stamp standard. So we were all very anxious to get to work and find something that find some common ground. So we wanted to work on the things that were most essential and add clarifications where we had found, particularly from those who had gone ahead and implemented 2.30, where there was some confusion. So we added a profiles document and a usage guide to hopefully make the adoption of the standard easier. And we split out the current mechanisms and historical mechanisms. There are some, being a 20-year-old standard, there's a lot of mechanisms that just aren't used or never, have fallen out of current favor, and so that we put those in the deprecated kind of document so they are separated. They're still supported, but we haven't dropped them, but it's more not really recommended. And we've been all together learning the OASIS formal standards process. For myself, this is coming from the old way that we did the PKCS 11 standards under RSA. Things were very different. And it's been great having Bob as my co-chair. As he noted, he had been working with KMIP through the process since 2009, so he had a lot more background. And then others as well that had been on different standards body in OASIS had helped us navigate all of this process. Next slide, please. So in June 2014, we had our 15-day public review of the committee-approved specification. It took us a while to get there, so that was about a year of work to get there. And in this last November, we had our special majority votes to approve PKCS 11 drafts as committee specification. So we're almost there, and that's why we're meeting here with you today to turn this into a real, formal, official OASIS standard. Next slide, please. So what are the things that we worked on? New mechanisms. The old standards only covered TLS 1.0 and 1.1, so we added mechanisms for TLS 1.2. This was an area that was a bit tricky, as we had made an earlier attempt by the committee before it came into OASIS was to make the TLS specific mechanisms more generic, but it turns out the specification for the underlying TLS has changed enough where we had to come up with a new mechanism name and make sure that that would work properly there. We did updated mechanisms and attributes. It seems like there's always new modes coming out for AES, so those were added to the standard as well. And we made updates to DSA, RSA, SHA, and ECDSA. There's been a lot of clarifications. For example, we have some issues with raciness in C-closed session, and we also added new error codes, particularly around ECC and a few other things as well, that people who have been implementing have said, gee, I really wish there was a way to do X. All right, thank you. Next slide, please. So I touched on TLS 1.2 a little bit earlier, but it differs from 1.0 and 1.1 in that the base hash functions used in the underlying TLS pseudo-random function, the PRF, can be negotiated. So we had to do things very differently here. We also added a TLS KDF for doing the key material exporters, and 2 MAC functions for use with TLS 1.0 and 1.1. All right, next slide, please. AES mechanisms, there's, like I said, there are always, it seems like there's new modes for AES, which is how the standard was designed so it can grow. So we've added CMAC, GMAC, XCBC MAC, XCBC MAC 96 as well, and new modes for encryption and decryption, GCM, CCM, which had come forward from 2.30, and CFP 128. So the big win we get here is with this new version of the standard, you'll be able to get authenticated encryption using AES. Next slide, please. We also added SHA-512T. It's identical to SHA-512, except for it has an initial hashes are given by IV generation, and the output is constructed by truncation. SHA-512 is faster than SHA-256 on some 64-bit CPUs, but I know there is desire from some applications and consumers of PKCS 11 where they are space constrained to have the hash take up less room, and so that's where the truncation is becomes quite valuable there. Thank you. Next slide. We also updated, as mentioned before, DSA, ECDSA, and RSA PKCS 11 functions. Next slide, please. And we've already started talking about what's next. So for those of you who are familiar with the OASIS process, it can seem slow. There are, as Bob mentioned, we're just completing our 60-day review period. And 60 days is a long time. We don't want to just sit around and wait. So we have started talking about what's next, what can we do afterwards. So next slide, please. So hence version 3.0. We're looking at more simplifications. The API over the last 20 years has become quite complicated, and there is a lot of overhead that you have to do with initialize, get slot lists, get mechanism lists, before you can even think about doing an encryption operation or a simple digest. So we are looking at possible parallel API, so we would have backwards compatibility, and all the new functionality would be added in the newer API, and that would be lighter weight, easier to get going, and easier to get started up. We want to have improved key management, better PIN management fixes, and we're open for new ideas, so we are always looking for new committee members, people who are interested in cryptographic standards, who are users of PKCS 11 or would like to be. Next slide, please. So for more information, I would say there also is a proposal for a crowdsource session at RSA this year. So I've never spoken at RSA before, and I would love to have that opportunity, and I would appreciate your vote. So anyone, even non-attendees for RSA, can vote for this session. I'm going to talk about PKCS 11 and KMIP, how they can work together, and how vendors using open standards can, customers using open standards can escape vendor lock-in. So that's very exciting, and this is something that we've seen. As I work on Solaris, as noted, and we've seen people who write applications for Linux. They run on Solaris because we both support PKCS 11, and that's been a great way to adopt new software, and been a great help for our customers, so they don't have to really worry about the underlying platform because there is a standard. KMIP is very similar in that it's a standard way for handling key management and doing interoperability. So I would like to talk about that at RSA. As you all know from Bob's history, there is a lot of RSA history in this, and I think the RSA conference would be a great place to talk about that. So that is a crowdsourced activity. This is a new thing RSA is doing. They are going to let the Internet become their selection committee about deciding who will and will not be able to talk at this year's conference. They still have the standard slots that they have already filled. This is going to be 12 slots that they will be filling with this Internet vote. So please do and go and vote. I would really appreciate it. The link has been handily provided right here. And you can also contact myself and Bob at any time. Our email addresses are provided there. And next slide, please. And we have links here to the documents, so you can see where we are and what we're doing here, as well as the technical committee website. You can always find newer information there. And CryptoSense has actually written some very amazing blogs that will walk you through the changes that we've done in this new version of the standard and older ones, and how to work on adoption of the standard. And I think it's a really great resource. All right, I believe that is our last slide. So at this time, I think we can open up for questions.
So you'll see on your on your screen that there's a place to enter in questions. Please do if you have any. And of course, you're always welcome to send them directly to Valerie or to me on email. We're always happy to get questions. I would also, as you're thinking about any questions, there's one other thing I forgot to mention. In addition to the crowdsourced session that Valerie mentioned, there will also this year again be an interop, PKCS interop that I'll ask Valerie to speak to in a moment at RSA conference in the exhibition hall. So over and above the crowdsourced session, it's a great opportunity to see the OASIS as an organization and PKCS 11 as a TC in particular, working within a major customer, a major industry event. So if you are coming to the conference, it would be great to have you join us. And in fact, if you're not yet planning to come to the conference, there is a free registration code available from OASIS that would allow you to come and see us in the exhibition hall. So we hope you might do that. Valerie, do you want to say a little bit about the Interop and what's being planned for 2015?
So we'll be sharing the Interop booth with also the KMIP committee. So we are very closely related committees, obviously with key management and cryptography going hand in hand. So some vendors are participating, I believe, again this year in both sides of PKCS 11 and KMIP, and that kind of is nice the way Jane gets us set up back to back. And a lot of the vendors that are there do support both KMIP and PKCS 11. So it's a really great way to find out what we're doing, how we're working together, and the different testing that we're doing. This is being led by Cryptsoft and running the Interopt as well there. So they're keeping us all in line and making sure that we're doing the right things to be able to work together. And in general, Bob, you showed that slide earlier about clients and versus libraries. And our goal here is to make sure that if someone writes a library for one operating system or for working with one HSM, that it will work with another HSM as well or on top of another operating system. And that it's the best thing for all of us, really, because, like I said, customers don't have to worry about what the underlying operating system is or what the underlying hardware key store is. As we know, vendors, customers do change which vendors they use for different types of systems. They have different needs. They might need FIPS 140 level 1 for one task, and they might need FIPS 140 level 3 for another, and it's great if they can have one application and it works with everything underneath. So we had a lot of fun doing our Interop last year and getting everything to hook up and run together, and this year is shaping up to be quite a good time as well.
Great. Thanks, Valerie. Chad has reminded me the vote for on the version 2.40 specifications will begin next week. So we very much hope that you'll support us in this. We think the standard really represents an extremely important OASIS standard, one extremely important for the industry, represents a tremendous amount of work by all of us on the committee, and we believe well deserving of your support. Again, if there are any questions, please don't hesitate to contact Valerie and me, and we really do look forward to hearing from you and to your support. Jane, I think over to you then for wrapping up.
Absolutely. Well, thank you both very much. Again, as Bob had mentioned, if you have any questions about anything in the document, by all means, reach out to either Valerie or Bob directly. A video recording of this webinar will be posted on the OASIS YouTube site and accessible to all. So if you missed any portion of it, by all means, check there in a little bit, and it'll be loaded up there. We thank both Bob and Valerie for giving us their time and expertise on this subject, and we do encourage everyone to vote, 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 vote.
Thanks again, Jane.
Thanks
everyone for joining us.
Bye-bye.